50 years back, the idea that obscure minerals hidden beneath the Earth's surface would become weapons in a high-stakes global power struggle seemed almost unthinkable. Yet today, these elements, known collectively as rare earths, sit at the very heart of technological sovereignty and economic independence. When Beijing tightened its grip on rare earth exports, the world experienced a collective awakening. Nations that had grown comfortable depending on Chinese supply chains suddenly found themselves vulnerable. The realization was stark. Critical materials for everything from smartphones to fighter jets could be cut off at a moment's notice. This sparked a worldwide scramble as countries rushed to secure alternative sources, attempting to break free from what many saw as dangerous dependence on a single supplier. South Korea, a nation that has built its modern identity around technological excellence, found itself in a particularly precarious position. In June 2024, a major South Korean corporation announced an ambitious solution: a $3 billion rare earth processing facility in Kazakhstan. The project was hailed as a strategic masterstroke, a pathway to independence that would secure the raw materials needed for the country's booming electric vehicle and semiconductor sectors. But, ambition and reality don't always align. Within 12 months, this facility, built with such high hopes and enormous financial commitment, began showing serious cracks. Production targets went unmet. Supply chains proved unreliable. Technical challenges that seemed solvable on paper became insurmountable obstacles in practice. What was supposed to be South Korea's declaration of resource independence instead became another cautionary tale about the complexity of rare earth processing. So what went wrong? How did a multi-billion-dollar strategic investment collapse so quickly? And perhaps more importantly, what does South Korea do now, caught between technological ambition and geopolitical reality? When Beijing tightened its grip on rare earth exports, the world experienced a collective awakening. Nations that had grown comfortable depending on Chinese supply chains suddenly found themselves vulnerable. The realization was stark. Critical materials for everything from smartphones to fighter jets could be cut off at a moment's notice. This sparked a worldwide scramble as countries rushed to secure alternative sources, attempting to break free from what many saw as dangerous dependence on a single supplier. South Korea, a nation that has built its modern identity around technological excellence, found itself in a particularly precarious position. In June 2024, a major South Korean corporation announced an ambitious solution: a $3 billion rare earth processing facility in Kazakhstan. The project was hailed as a strategic masterstroke, a pathway to independence that would secure the raw materials needed for the country's booming electric vehicle and semiconductor sectors. But ambition and reality don't always align. Within 12 months, this facility, built with such high hopes and enormous financial commitment, began showing serious cracks. Production targets went unmet. Supply chains proved unreliable. Technical challenges that seemed solvable on paper became insurmountable obstacles in practice. What was supposed to be South Korea's declaration of resource independence instead became another cautionary tale about the complexity of rare earth processing. So what went wrong? How did a multi-billion-dollar strategic investment collapse so quickly? And perhaps more importantly, what does South Korea do now, caught between technological ambition and geopolitical reality? The technology powerhouse's hidden vulnerability. To understand South Korea's rare earth predicament, we first need to appreciate just how deeply technology runs through the nation's economic DNA. Walk through any electronics store anywhere in the world, and you'll encounter South Korean innovation at every turn. Samsung, LG, SK Hynix, these aren't just corporate names, they're global technological institutions. LG dominates the home appliance landscape, with its smart televisions, refrigerators, and washing machines reaching consumers in over 160 countries. The company's energy division, LG Energy Solution, ranks among the world's top 3 battery manufacturers, supplying power cells to automotive giants like Tesla and Volkswagen. Then there's Samsung Electronics, a conglomerate whose reach seems almost limitless. From the semiconductors that power our devices to the stunning displays we stare at daily, from the smartphones in our pockets to the cutting-edge batteries driving the electric vehicle revolution, Samsung has established what can only be described as a complete technological ecosystem. Recent financial data reveals the scale we're talking about. In 2024 alone, Samsung Electronics generated revenues approaching $230 billion. This represents more than corporate success. South Korea has methodically constructed an entire industrial architecture around electronics manufacturing. The country has achieved something remarkable: vertical integration across the entire value chain, from raw chip fabrication to finished consumer products. But here's the problem that keeps Seoul's policymakers awake at night. Every single one of these products, every smartphone, every electric vehicle battery, every semiconductor chip, depends fundamentally on rare earth elements. These aren't called rare earths because they're necessarily scarce in the ground. The term is somewhat misleading. Rather, they're difficult to extract economically and even more challenging to refine into usable forms. Yet they're absolutely irreplaceable in modern electronics. The powerful magnets in electric motors, rare earths, the phosphors that create colors in displays, rare earths, the catalysts that make industrial processes possible, again, rare earths. South Korea does possess domestic rare earth deposits. Geological surveys from 2023 indicate reserves of approximately 147,000 tons. Concentrated primarily in North Chungcheong Province's Cheongju area and Gangwon Province's Hongchun region. The ore bodies are substantial, roughly 23 million tons total, with rare earth concentrations ranging from 0.1 to 4.7%. On paper, these reserves could theoretically satisfy South Korea's needs for half a century. But having ore in the ground and being able to use it are entirely different propositions. The real challenge lies in what happens after mining, the purification and separation processes that transform raw ore into usable rare earth elements. This is where China has established what amounts to a technological moat. Chinese companies have spent decades perfecting these techniques, developing proprietary extraction methods and refining processes that competitors struggle to replicate. The economics tell the story clearly. South Korean companies attempting to process rare earths domestically face costs of approximately $7,200 per ton. Chinese facilities, leveraging superior technology and economies of scale, operate at costs around $2,334 per ton, less than a third of what South Korean producers would pay. Given this massive cost differential, South Korea has made the logical economic choice: import processed rare earths rather than develop domestic processing capability. Currently, the country sources its rare earth materials from China, the United States, and Australia. But the dependence is heavily skewed. Roughly 80% of South Korea's rare earth imports flow from Chinese suppliers. In 2021, to put this in concrete terms, South Korea purchased about 20,000 tons of rare earths from China, transactions valued at over $500 million. For years, this arrangement worked smoothly. China supplied high-quality materials at competitive prices. South Korea's technology sector hummed along, and both nations benefited from the relationship. Then the geopolitical winds shifted, when trade becomes weaponized. The election of President Yoon Suk-yeol marked a turning point in South Korea's approach to China. The new administration aligned itself more closely with Washington's strategy of technological containment, implementing restrictions on semiconductor sales to Chinese companies. Seoul was making a choice: strategic alignment with the United States over commercial relationship with China. Beijing's response was measured but unmistakable. In late 2023, China announced export controls on rare earth processing technology. This wasn't targeted specifically at South Korea. The regulations applied broadly, but the impact on Korean companies was immediate and severe. The ban effectively closed off any possibility of South Korean firms acquiring the technical knowledge needed to develop domestic processing capabilities. Here's where the situation gets particularly interesting. The export controls didn't cut off rare earth material supplies to South Korea. Chinese suppliers continued to sell processed rare earths to Korean customers. What China restricted was the technology transfer that would allow other countries to compete with Chinese rare earth processing. For South Korea's technology sector, this created an uncomfortable realization. The country's electronics giants, companies at the absolute forefront of semiconductor and display technology, remained fundamentally dependent on Chinese rare earth supplies without any realistic near-term alternative. This dependency wasn't just about economics anymore. It had become a strategic vulnerability. The Kazakhstan Gamble. Facing this new reality, South Korean policymakers began looking for options. They needed a partner with substantial rare earth resources, but without the geopolitical complications that came with Chinese supply. Their search led them to Central Asia. In June 2024, South Korea formalized a major partnership with Kazakhstan, one of the world's most resource-rich nations. The agreement centered on a bold plan: invest $3 billion to construct a state-of-the-art rare earth processing facility on Kazakh soil. The proposed site sat less than 300 kilometers from Kazakhstan's capital, Astana, encompassing more than 600 acres. The design called for one of the most technologically advanced mineral processing facilities in the region. Beyond the processing plant itself, the partnership included plans for an international standard chemical analysis laboratory dedicated to mineral testing, research and development, and the establishment of technical standards for rare earth processing. If everything went according to plan, this facility would transform South Korea's supply picture. Internal projections suggested the plant could reduce South Korean dependence on Chinese rare earths from 80% down to approximately 23%. For those unfamiliar with Kazakhstan, some context is helpful. This is one of the planet's largest landlocked nations, spanning 2.72 million square kilometers, roughly equivalent to Western Europe. The country's geological wealth is extraordinary. Surveys have identified more than 90 distinct mineral resources beneath Kazakh territory. When it comes to rare earths specifically, Kazakhstan ranks second globally in reserves, controlling about 15% of the world's total. Of the 34 critical metals currently identified as strategically important, Kazakhstan possesses the refining technology for 19 of them. The timing of South Korea's investment proved remarkably fortuitous. In April 2025, Kazakh geologists announced a discovery that sent shockwaves through the rare earth industry: a massive deposit in the Karaganda region, approximately 420 kilometers from Astana, extending 300 meters below the surface. Preliminary estimates suggested this single deposit contains up to 20 million tons of rare earth elements, rich in critical components like neodymium, cerium, and lanthanum, with average concentrations of 700 grams per ton. If these estimates prove accurate, this discovery could catapult Kazakhstan to third place in global rare earth reserves, trailing only China and Vietnam. Against this backdrop, South Korea's decision to build a processing facility in Kazakhstan seemed not just prudent, but potentially brilliant. Here was a resource-rich partner with geological wealth, existing refining expertise, and no apparent geopolitical conflicts with Seoul. The project launched with considerable fanfare and high expectations. Then reality set in. The Unraveling. Just 12 months after operations began, the Korean rare earth facility in Kazakhstan found itself in crisis. The problems weren't minor operational hiccups that could be solved with time and adjustment. They were fundamental challenges that threatened the entire project's viability. The first major issue centered on purification efficiency. When processing ore imported from Mongolia, the facility's yield rates hovered around a dismal 12%. Think about what this means in practical terms. For every 10 tons of ore fed into the system, barely more than 1 ton of refined rare earth elements emerged from the other end. The remaining 90% was essentially wasted. Compare this to Chinese facilities, where domestically developed extraction agents routinely achieve yield rates of 98% or higher. Chinese operations don't just extract rare earths more efficiently. They've also developed secondary recovery processes that pull additional valuable metals from what other facilities would consider waste material. The efficiency gap wasn't just about lost material. At 12% yield, the entire economic model of the facility collapsed. The ore costs, processing costs, and infrastructure investments had all been calculated based on much higher recovery rates. At actual performance levels, the plant was consuming value rather than creating it. But the technical problems went deeper than purification efficiency. The Korean facility lacked even basic testing capabilities. To analyze ore composition, a fundamental requirement for optimizing processing, samples had to be sent to Chinese laboratories. Each test cycle consumed 7 days as samples traveled to China, underwent analysis, and results made their way back to Kazakhstan. This created a production rhythm problem, making it impossible to respond quickly to variations in ore quality or adjust processing parameters in real time. Then there was the electricity situation. Kazakhstan's power grid, particularly outside major urban centers, relies heavily on infrastructure inherited from the Soviet era. In the winter of 2024, the Korean facility experienced firsthand what this means. A sudden voltage drop, the kind of power fluctuation that modern grids are designed to handle, fried centrifuges valued at tens of millions of dollars. This wasn't just expensive in terms of equipment replacement. The specialized components needed for repair could only be sourced from China, requiring air freight that consumed what would have been 6 months of facility profits. A single equipment failure effectively wiped out half a year of operations. By contrast, Chinese rare earth operations in Kazakhstan had anticipated these infrastructure challenges. The Jiangtong Tungsten project, for instance, invested in dedicated substations and transmission lines from the project's inception, ensuring stable power delivery 24 hours a day. This infrastructure investment, while substantial, came in at nearly 40% less than what the Korean facility ultimately spent on power-related equipment damage and repairs. Perhaps the most crushing problem, though, was one that should have been apparent from the beginning. Energy costs. Kazakhstan generates approximately 82% of its electricity from coal-fired power plants built during the Soviet period. These facilities are shockingly inefficient by modern standards, burning 350 grams of coal to produce each kilowatt-hour of electricity, 120 grams more than comparable Chinese plants. That's a 50% efficiency penalty baked into every unit of power. The transmission system compounds the problem. Kazakhstan's aging electrical grid loses roughly 15 kilowatt-hours for every 100 kilowatt-hours transmitted, losses that would be considered catastrophic in modern power systems. For industrial facilities located far from generation sources, this means paying for electricity that never reaches their equipment. When negotiations began, Kazakh authorities had quoted an attractive industrial electricity rate of 5 cents per kilowatt-hour. This looked competitive on paper, but the reality proved far different. After accounting for various surcharges, transmission fees, and administrative costs, the actual electricity price the Korean facility paid jumped to 12 cents per kilowatt-hour. To put this in perspective, rare earth industrial parks in China's Inner Mongolia region, where much of China's rare earth processing occurs, operate with electricity costs around 6 cents per kilowatt-hour. The Korean facility was paying double for an essential input that represents a major portion of processing costs. Location created another insurmountable economic challenge. The facility sits roughly 2,000 kilometers from the nearest ocean port. Transporting 1 ton of rare earth ore to or from the facility costs approximately $500. For a low-margin industrial operation, these transportation costs alone consumed virtually all potential profits. Add up all these factors: poor purification efficiency, electricity costs double what competitors pay, massive transportation expenses, frequent equipment failures requiring expensive repairs, and you have a recipe for commercial disaster. A facility that absorbed $3 billion in investment found itself hemorrhaging money within its first year of operation, with no clear path to profitability visible on the horizon. This wasn't South Korea's first attempt to diversify away from Chinese rare earth supplies. The country had tried before, with similar results. In February 2023, Seoul signed a long-term cooperation agreement with Mongolia, a country with substantial rare earth deposits of its own. The plan seemed straightforward. Mongolia would export rare earths to South Korea through China's Tianjin port, leveraging existing infrastructure for efficient transport. Shortly after signing the agreement, Mongolian officials approached China with a request to lease access to Tianjin port for rare earth exports. The request was met with silence. Months passed with no progress on the port access agreement. As of now, more than 2 years later, the proposal remains in limbo with no clear resolution. Without Chinese cooperation on port access, Mongolia faces a geographic nightmare. The country is doubly landlocked, surrounded entirely by land, with its nearest neighbors also lacking ocean access. This means any export to South Korea requires either passing through Chinese territory or taking a circuitous route through Russia. Some suggested air transport as an alternative, but the mathematics of air freight for rare earths simply don't work. South Korea imports over 3,000 tons of rare earths annually. A typical cargo aircraft carries less than 100 tons. Moving South Korea's annual rare earth requirement by air would require more than 30 dedicated cargo flights, at costs that would dwarf the value of the materials being transported. Beyond economics, rare earths present handling challenges that make air transport impractical. The materials require specific storage conditions and careful handling. There's no precedent anywhere in the world for large-scale rare earth transport by aircraft, and for good reason. It's technically difficult and economically absurd. The Mongolia partnership, like the Kazakhstan processing plant, ran headlong into the reality that geography and infrastructure matter tremendously in commodity industries. You can't simply wish away the need for ports, railways, and processing facilities that took decades to develop. South Korea's rare earth situation isn't entirely hopeless, though. Recent political shifts have created an opening. The election of a new South Korean president has ushered in a period of diplomatic thaw between Seoul and Beijing. The relationship remains complicated, but the tone has shifted from confrontation toward cautious pragmatism. In this new atmosphere, China has demonstrated some flexibility on rare earth exports. Beijing has established what officials call a green channel for South Korean rare earth purchases, approving procurement applications from multiple Korean companies. On the surface, this looks like a return to the pre-2023 status quo, with Chinese suppliers once again willing to do business with Korean customers. But there's a crucial difference this time. China has attached very specific conditions. South Korean companies can purchase Chinese rare earths, but they must agree to strict no-resale provisions. The materials cannot be transferred to third parties, and critically, cannot be redirected to the United States. The restriction extends particularly to any use in American military systems or defense-related industries. To ensure compliance, China requires all Korean purchasers to submit formal written commitments pledging not to resell or redirect the materials. But Beijing has gone further, developing a technological enforcement mechanism. China has created what it calls a rare earth traceability chip, a tracking device that must be embedded in rare earth products sold to South Korean companies. This technology enables full supply chain monitoring, allowing Chinese authorities to track where materials go and how they're used throughout their life cycle. The implications are significant. This isn't trust-based enforcement, it's technology-enabled verification. If rare earths purchased by a Korean company somehow end up in American defense systems or get resold in violation of the agreement, China will know. The consequences for breach are equally clear: immediate supply cutoff and severe financial penalties for the companies involved. This represents a new model for rare earth trade, one where the supplier maintains oversight even after sale. It's supply chain management as geopolitical tool. South Korea's rare earth struggles illuminate a broader challenge facing many technologically advanced nations. The modern global economy was built on assumptions of free trade and reliable supply chains. Companies could source materials from wherever offered the best combination of price and quality. Countries could specialize in what they did best, trading for whatever they couldn't produce efficiently themselves. Rare earths expose the limits of this model. When a critical material concentrates in one country's hands, whether through geological accident, technological advantage, or deliberate industrial policy, dependence becomes vulnerability. And in an era of great power competition, vulnerability becomes leverage. China's dominance in rare earth processing didn't happen by accident. It resulted from decades of investment, environmental externalization that Western countries wouldn't accept, and patient development of technical expertise. Other nations can theoretically recreate this capability, but not quickly and not cheaply, as South Korea's Kazakhstan experience demonstrates. The $3 billion processing facility that was supposed to provide independence instead proved how difficult breaking free from established supply chains really is. It's not enough to find alternative resources. You need the processing technology, the infrastructure to support operations, the technical workforce with relevant expertise, and the economic conditions that make the entire enterprise viable. Miss any piece, and the entire project collapses. For South Korea, the path forward remains unclear. The Kazakhstan facility continues to struggle, burning through capital without achieving anything close to viable operations. The Mongolia partnership remains stalled on the seemingly simple question of port access. Domestic processing remains economically prohibitive. This leaves South Korea exactly where it started, dependent on Chinese rare earth supplies, now with the added complexity of Beijing's monitoring requirements. The country's technology giants, Samsung, LG, SK Hynix, continue to produce cutting-edge products, but they do so knowing that critical inputs flow through supply chains they don't control. The question of whether China should reopen rare earth supplies to South Korea, or any country, misses the larger point. China has reopened those supplies, but on Beijing's terms, with Beijing's conditions, subject to Beijing's monitoring. South Korea can access the materials it needs, but it does so as a dependent partner rather than an independent customer. This is the new reality of critical material supply chains in an age of geopolitical competition. Resources aren't just commodities traded on open markets. They're tools of statecraft, leverage in broader strategic contests, and insurance policies against technological encirclement.